Hello, in this podcast we're going to be explaining the importance of soil to agriculture. We'll also be describing the structure of soil, and we'll also be looking at some of the causes and consequences of soil erosion and degradation, though much of this stuff we'll be looking at in future podcasts. The reason why soil has its own podcast here is because soil is vital for agriculture, and agriculture is the practice of raising crops and livestock for human use and consumption. And you also need to know that cropland is the land that's used to raise plants for human use, and rangeland or pasture is the land that's used for grazing livestock. And these two cover 38% of the Earth's land surface. What is soil? Well, a lot of this you learned back in earth science. Well, 5% of it is organic matter, half of it is minerals, and 45% of it is pore space consisting of air. The amount of the pore space will of course depend on the condition of the soil. Like in some places in New York City, the soil is very, very compacted, which means that there's not much in the way of pore spaces there. The soil has been fairly well crushed, and that has serious consequences in terms of plants like trees being able to grow. The organic matter in the soil consists of both living and dead organisms and also decaying material. The living organisms can contain quite a bit. They can contain up to 100 million bacteria, 500,000 fungi, 100,000 algae, 50,000 protists. And if you look, this shows relationships of the ecosystem of soil, and soil itself is an ecosystem. There are producers in there, like you've got plants that there are plants that form the backbone of the energy, and there are things that eat the plants themselves. Also, decaying matter go in there, and the bacteria eat those in the soil, and things eat things. Then you have organisms that eat those, and organisms that eat those, and so on and so forth. Now, this diagram here shows how soil itself forms, and this goes together with succession, which is what we taught about before. Like primary succession begin with bare rock, and now we're looking sort of like underneath rather than what goes on top. Start up with bare rock, which weathers, and you end up with broken down parent material, and you end up with some organic material on top, where you've got the pioneer organisms on top, like the algae and the lichens, and those help break it down even further. And that starts to make a primitive horizon, which is the topsoil. We'll get into what those are in just a little bit later on in this podcast. Humus basically is a form of organic matter. We'll get into that also just a little bit. And as the parent material, the bedrock, continues to break down, the soil can get thicker and thicker, and you can have more and more things grow. And you see that layers will appear in the soil. Look closely at the soil right here. You can see that soil does form distinct layers. You see each color there is a layer. The soil here has an O horizon, an A horizon, a B horizon, and a C horizon. This diagram here shows those also. Not all soil will have every single layer that's labeled here in the notes, but basically these are the general layers that you'll see in many but not all. And in some ecosystems there's some layers that will be missing. For example, here in New York City, frequently you find the O horizon missing. You'll have those mostly like in the grasslands. An O horizon is an organic litter layer, where you just have humus, which is a sticky brown insoluble residue from partially decomposed dead organisms. And right here is a picture that shows humus. It just is organic material. There's really no minerals inside humus. Many soils don't have that layer, but many soils do have the A horizon. The A horizon is topsoil, and this is composed of organic material and sediment. And this is quite essential for agriculture because this is the layer which has most of the nutrients in it that plants will need to grow. The thickness of this layer is both dependent on the rate that organic material will decay, and it's also dependent on the amount of precipitation. because what happens is that when it rains, that will wash the nutrients down. In that layer where you see the nutrients being washed away, that's called the E horizon, called the alluviated or leached zone. And the layer of soil where that stuff is leached to is called the B horizon, and that's called the subsoil. This phenomenon is quite important here in the Northeast because the one thing which can cause a lot of the nutrients to be washed down is acidic water or acid rain. And how water can become acidic? And how water can become acidic? And become acidic by having coal-burning power plants that have a lot of sulfur in them that will make sulfur dioxide, release sulfur dioxide, which will combine with water to make sulfuric acid, makes acid rain. When that acid rain lands in the soil, that will wash a lot of nutrients deep down in the soil. Plants can't get to it, and they will then die from nutrient deficiencies. Below the subsoil is the C horizon, which is also called regolith because it's just weathered rock, not much in the way of organic material at all. And below that is the R horizon, where R stands for rock. It's just the solid bedrock. Now we're going to look at how to characterize the soil. Soil can be characterized by its color. If it is rich in humus, then it would be black or dark brown. If the nutrients have been leached out of it, then it'll be pale gray or be white. And I just talked about pH. How pH can be very important. pH is a measure of the acidity. Structure is the clumpiness, and clumpiness is how much it sort of clumps together. And that's sort of like a measure of how compact the soil is, how big the pore sizes are. If the soil is too clumpy, then the roots can't penetrate. That's going to be a serious problem, particularly for, say, young saplings. And also compact soil cannot absorb water. And this is a big problem here in New York City because the soil is very, very compact from the weight from all the buildings and all the people walking through. Texture is very important. It's determined by particle size. And soil is basically composed of three size mineral particles. What it's made of is not what we're talking about here, it's just the size. If the size is less than 0.002 of a millimeter, it's clay. If it's bigger than that but smaller than 2 millimeters, then it's silt. If it's large enough to see it, which is in 2 millimeters is the limit of that, then it's sand. And the texture influences the soil's workability and its porosity, and also its permeability too. If the particles are small, that means water and air have more difficulty passing through it. That slows the infiltration, which is how quickly water can enter the soil. And also it will limit how available the oxygen is available to the roots that are in there. So if the particles are very large, that means water will pass through it very quickly, and that will require frequent irrigation. If you look at this picture here that I took, this is in Queens. This is the same place where I filmed the introduction to our course, that first podcast. And this is cactus, prickly pear cactus that's growing in Queens. And you see the soil there is very sandy, and that's why cactus can survive there. It rains just as much there as it does here, but because the particle size of the soil is very large, it's just sand, the water goes through very, very quickly, so it has a lot of the conditions of a desert. Now if you look over here, this here is called a soil texture triangle. And you are going to have a lab where you're going to have to use a soil texture triangle, and you may end up having to use this on a test or on the AP exam. And the soil texture triangle will help you find out the texture of a soil. Right? Let's say, for example, there is a soil which is, let's say it's 70% clay, and let's say it's 10% silt, and 20% sand. How do we use this triangle here, the soil texture triangle, to find out what kind of soil we have? Well, here's what you do. always start out first with clay. Clay starts here at 0% up to 100%. And we're going to go around clockwise. You start off with clay, and which line do we use here? You see we got two lines here. We use the line which goes to the next one we're going to. So we go clockwise, so we're going to go from clay to silt. So here's 70%. So we just go straight across to 70. Next is silt. Silt is 10%. Now silt goes from 0 to 100 down here. Now we're going clockwise. Silt to sand. So we use the line going from silt to sand. It's down like so. And then the last one, we're down here for sand. Sand goes from 0 to 100 over here. And clockwise it's going towards clay. So we use 20% going straight up here to clay, and where all three of them merge here, this is the type of soil that we have here. Let's do another. Let's make it another one. It's 20% clay. And then let's do 40% silt and 40% sand. So 20% clay over here. We're going to silt next, so straight across to silt. Next one, silt 40%. Here's 40. We're going down to sand. Straight down, because clockwise to sand, that way. Next, 40% sand, 0 to 40. Here's sand, 40. We're going clockwise. Next one is going this way. So we're here in loam. And loam actually is a type of soil which is really good for farming in section. The type of soil will change depending on the biome, because in the biome the climate changes, and that will change what the horizons look like. This here is a forest soil. This one here, they don't really show the E horizon, and the B horizon is sort of combined with the E horizon. But you notice the A horizon is very, very thin, and the reason why it's so thin is because it rains a lot in the deciduous forests, so that will wash away a lot of the nutrients. So the topsoil is thin, so the B horizon is very, very thick. But when you look in a grassland, there's not a lot of rainfall. There was, then it wouldn't be a grassland, it would be a forest. But because the grassland is, because there's so little rainfall, that means that the topsoil can really build up, so that the A horizon would be very, very thick, and the B horizon would be very, very small because so little is leached. And also the dead plants and all the roots from all the grasses and all the grasses, you'll end up with an O horizon in the soil too. And because of the huge topsoil, that will make the grasslands such good farmland, and that's why the Midwest is America's breadbasket. Come to a desert, there's very little rain, so there's very little life. Like here, you'll find, unless someone has recently cleared the land, you won't see bare soil. You'll see vegetation everywhere. Same thing in a grassland. Go to a desert, you'll see bare soil, a lot of bare soil. So because there's so much bare soil and so little plants, the A horizon is very, very small. But when it does rain, it pours. So that means that the B horizon and the E horizon are huge, because so much gets leached down. Now, with stuff being washed down, that also comes to erosion, which can be a serious problem too for farmers. Erosion is transportation of sediments. Usually the transportation is by water or it can be by wind. When by water, there are three types of erosion, and this picture that you see here is a picture of sheet erosion. That just takes a thin layer off the land surface. This next picture here, you see those channels there, those are called rills. That's why this is called rill erosion. Small channels in the soil. If that problem continues, those rills will become enlarged. They can become greatly enlarged, and at that point can become gullies, and that's called gully erosion. And you can see how large those can become in this picture here. You can also end up with stream bank erosion, and that occurs along the banks of streams. Here's a little clip to show you stream bank erosion. So banks that can be quite established can be washed away, and it can be sometimes dramatic. Places where you find the highest erosion rates are in the United States and in Canada. And the USDA, which is the United States Department of Agriculture, reports that 69 million hectares, or 170 million acres, of United States farmland are eroded at rates that decrease productivity. That means that the erosion rates are greater than 5 tons per acre. So it's being eroded faster than the soil is being formed. So in other words, that the erosion rates have turned our renewable resource of soil into a non-renewable resource. Why is erosion such a problem? Well, take a look at this picture here. This demonstrates what our intense farming practices do and how they exacerbate the erosion. You see how you can see bare soil, and how I said before, normally you don't? Normally everything is covered with vegetation. So the vegetation, the roots, will hold on to the soil. So when it rains, the soil stays in place. When we're growing row crops like corn and soybean, that leaves the exposed soil, and so that soil can be washed away when it rains. Also, deep plowing will disturb the soil and makes it easier to wash away. When we add lots of herbicides, which will kill other plants, yes, it will make our crops grow much easier, but it will also leave exposed soil because other plants won't be growing. Also, in arid areas, having goats and sheep and cattle grazing and overgrazing in areas, that will destabilize the soil because they're eating and killing the plants, and that soil will blow away, and that will cause desertification, which is turning land into a desert, and that is a problem in quite a few areas in the world. And we'll get into this later too, and I'm going to show you a clip in a moment that shows how deserts are growing, particularly in China. Over the past 30 years, they've lost an area equal to Indiana to desert.
Driving across the plains of the Gobi Desert, there's a deceptive calm. But within seconds, the wind can change, and suddenly you're in the eye of a sandstorm.
20 meters visibility, 10 maybe.
The Gobi is a hungry desert. When it's on the move, nothing can stand in its way. This desert is moving at about 5 meters every year, and that means that there are now 4,000 villages in China in danger of being swallowed up by the sands. 5 meters doesn't sound like much, but it adds up to an area the size of Kent, lost to the Gobi every year. Muto village will be the next to go, smothered by the moving sand.
It's very bad for our land. The summers are too hot now, and in the winter the sandstorms come. It makes life very hard.
Too many people and too much farming are part of the problem here. Now scientists say climate change is exacerbating it. The storm eventually begins to die down, but the Gobi is unstoppable. In Chinjar village, it's already too late. The desert has arrived on its doorstep. They've tried planting trees to try to hold back the dunes. Still, the desert marches forward. This used to be an oasis. Now the land is parched, and so are its people. In Mrs. New's kitchen, the taps run dry. Everyone here is limited to just 1 hour of running water a day. Yin Guilan is a cotton farmer. She lives on less than £1 a day. And like a third of the world's people, she's never heard of climate change. But she's menaced by its effects.
This year, the cotton didn't grow properly, and our profits were wiped out. The sandstorms came through here and destroyed our crops.
They might not know it, but for some of the world's poorest people, a changing climate isn't something that could happen in the future. It's already looming over them. Holly Williams, Sky News, Chinjar village in the Gobi Desert.
Now we come to our concluding questions. Question number 1, what are the components of soil? Question number 2, what is humus? Question number 3, why is topsoil important? Question number 4, which soil texture is good for farming? Question number 5, which countries have the highest erosion rates? That concludes this podcast, and I'll see you in class tomorrow.